This is not going to be a session where you are going to learn how to program in ClojureScript in half an hour, right? But almost, okay? It can be really very, very simple. At PALO IT, we build quite complex applications mainly in the banking domain. So we build digital user experiences for people that have demands that can be really tough to fulfill, right? So in order to deliver the right solution, what we choose to do is not to go and just design and develop and that's the end of it, but to have a process which is more iterative, according to design thinking techniques and fast prototyping. So we want to put something that is working in the hands of the users as soon as possible and get their feedback to adjust, propose new solutions, and do that before we ever talk about APIs or databases or all this stuff. ClojureScript is a functional language. It's a LISP. LISP is a long history in programming. It's more than 50 years old. Who has been developing in ClojureScript or any other LISP before here? 1, 2, wow. Okay, all right. So I'm going to be very, very fast, but don't freak. You're going to have the slides. There is a little repo, and there is a lot of documentation, okay? So what do you need to get started? You need to have the will to see beyond the parents, okay? If parentheses are too much for you, then it's over, okay? The next thing that you will need is a JDK. So I know when I say Java here, okay, but you just need to install it and you don't see it anymore, okay? Then you absolutely need structural edit tools. If you try to edit Lisp without the right tool, you are going to end up with a mess and you're not going to know where is your stuff broken. So don't do that, okay? Always try with Parinfer, which is today available for IntelliJ or Atom or all of these editors. So basically, that's Create React App, but 3 years ago, and with hot code reloading working, right? That's all you have to do. And once you are there, we can talk about the language, right? So that's about data types. That's it. The one thing you need to know is that in Clojure, everything is immutable, but one type, which is called an atom. The rest, if you say something is one is one forever. So syntax, I'm not going to go through all of this list. The goal is to show you that it's 1, 2, 3, 4, 5, and we are in React. I go back. So syntax, mainly what you want to know is about immutability. So line 9, if I define x as being 1, when I do increase x, what's the value of x? Okay, good. Some people are paying attention. What you have below here is really syntactic sugar. You don't need even the whole page to know about the syntax, right? That's all you need to know. You need to know a little bit about functions, but for JavaScripters, it's quite easy. Functions are first-class citizens. You can pass them, you can store them, you can transform them. Also, pretty much what you need to know is here. We have reduce, filter, map. We have some syntactic sugar because, unfortunately, Lisp reads inside out. Don't try to read line by line, okay? It reads inside out, but you can transform it with some nice thread macros. If you see the last example at line 26, it's similar to what is at line 22, but reverse, right? Means evaluate this, put it map increase on each of one, filter even, reduce +4. So for you JavaScripters, it's better to be done like this. Like this is the list, map inc, filter even, and reduce. That's it about functions. Another concept which is really important in Clojure, you will see it everywhere, is the concept of maps. In JavaScript, you have objects. Maps are slightly different. First, they are immutable. Wow. Second, you have an interface to deal with maps that you wouldn't have for objects, because objects you just assign stuff. This key equals that. There is nothing like equal in the sense of changing values in a Lisp, right? Equals means equals. So here you have assoc to, let's say I want to have in this map the value k associated to 2, the key, sorry, k associated to 2. Dissoc value, update a value is quite interesting, so it's line 14. When you want to change a value in a map, you are going to give to evaluate to a new map. But you do it functionally, meaning you will run a function on the map that will produce a new map. So typically, update key 2, I want to update the key k with increment. What do I get? Okay, thank you. So, of course, I get a new map with a key k that has value 3, right? If I want to fetch stuff out of a map, I use get. But there is a nice shortcut, which is line 18, which is just give the key, just give the map between parentheses, and you get the result. Get in is interesting because you have a path, k, I want k, 1, I want the first element, I want x, and I get x. And it also works with assoc in, update in. So you have the I would say orthogonal interface to either get one key or to get a path within a complex data structure. Why is it important? Because in Clojure, we build the whole application state, what you call the store, as a single object, a single map. So you need to be able to navigate within this data structure with such functions. So mutable state, I'm going to be very fast. If you want to mutate something, it has to be an atom. You mutate it in a functional way. You swap the value which is in the atom with applying a function to this value. So typically, if I swap the value in A with inc, what's the value of A? No, it's not 2. The value of A is an atom. You have to open the atom to see the value inside. Also, atoms are watchable. You can associate any function that you want to any change that will happen on the atom, which means typically render function for state change, right? Does it make sense? So React, well, this is a React component, this is a form. So as you see, we have one function, it's called HTML for this library. We give it a data structure, it's not JSX. JSX is code. This is a data structure. I can change the structure of the data here, and it will change my component. So we are done with what's needed to start with ClojureScript. Nevertheless, this is a very rich language. There are a lot of concepts that you can play with. You can do logic programming. You can do Go loops. You can do types if you want to create your own types. the message here is, if you want to learn ClojureScript, forget about this stuff. Just stick to what I just showed you, and you will be safe. So I guess now you would maybe want to see some real code. So again, I show it because it's going to be in a repo that if you wish so, you can fork and use. So what we have here is a normal browser. What we have here is a normal editor. What we have here is a normal console. And this is dev cards. That's the thing that you started at the beginning, your Create React app, okay? And what it gives you is a playground where you can focus on one issue that you are trying to solve, okay? So typically, this code here is rendered as a card. Of course, it's not browser reloading, it's code reloading, right? The browser did not reload. The state of my system is still intact. I reload only the functions, and the state actually is kept intact. We are going to see that a bit later. So let's go to a card which is a bit more complex. That's the card, right? So basically, static HTML. I insist this is all React technology behind the scene. Here we have a card which is a bit more complex in the sense that it's rendering with the help of state values. So if we look at the code here, we see that we have some state, that we are dereferencing this state to take some value out of it and render the component. The next level of complexity, if I may talk about complexity, is to have a reactive component. So this is here. Here I'm doing two things. Like the previous one, I'm reading from the state to render my component, but I also have an event which is going to increase the value which is in state when I click on it. And of course, it works. Nevertheless, if I choose to change my code and say, oops, and say no, I want to change for a decrease, notice that when I change the code and save, the value is still 5. That is very important. Of course, it's very simple here, right? But imagine when you deal with a lot of complexity, a lot of state in your application, several pages, several forms, and so on. I don't touch ever the reload button of my browser, okay? So I change to ink again, and it's increasing. Okay, a form, right? Now some magic. Right? So I have a sort of state debugger that is coming with dev cards that I can use with more complex components that have multiple parts, multiple, I would say, way to render and to act. So, typically here, I have a component which is really kind of reusable. I reuse it several times in my implementation. And same story. So you see I can navigate in my application back and forth, again, without filling the forms myself. And if I change the code, I change the form, I will see the new form in the living application. So that's it for the easy part of dev cards. This is really something you can do at home, and you will enjoy it. I mean, it does not hurt, right? If you try, of course, we do a lot of React, right? We also do create React app and, of course, own application templates and so on. But sometimes it can bite because there is so much to know with Babel and Webpack and everything, and JavaScript, of course. Here, you are really safe. That would be actually something you can put in the hands of non-programmers, I think. So, we're going to add a little bit more complexity, do some more fancy stuff. You can also use it, well, to write tests, okay? But it's not for that reason that I show it to you. It's because, okay, a good practice, we have a store, state, this atom thing. We have a reactive UI, okay? We can already work like that. But actually, Flux is really a good architecture. It's a good way to structure an application, to have a single dispatch entry point. What does it mean? Everything that's happening in my app is going through dispatch. The thing is, if you want to implement it in ClojureScript, look, it's one function, apply, store, function, arguments, that's it, done. If I want, I can, I have this commented part here. I'm not going to execute it because it's showing an alert, but I can log, I can maybe write an email to my support staff when an error is happening. I can do whatever I want at this point, so it's pretty much interesting. The idea being to show you that to implement the Flux architecture in ClojureScript is just natural. So I'm not going to go through all of this stuff. It's pretty much a complex example, meaning you have business rules. The advantage of working functionally on your state, like, oh, something changed, apply this function to the state. One thing very important is if something goes wrong, your state stays like it was. So that's kind of atomic transformations of state, which are a bit hard to obtain with Redux. You can do it if you are very careful, if you don't chain actions and do silly stuff. But with Clojure, it does not bite. You just do it straight away. Of course, the next thing you will want to do is to write a proper application. So you might want to start to write your application in a card, like this one. But then you need to run it outside of the card. You need to know a little bit more information. What you need to know is how to write a proper application. This one, okay, is very complex. Huh? It's incrementing a number. But it's got the structure. You have the UI, you have the actions, two actions, one for init, one for the button. You have a dispatch, so you have a Flux application. Now you want to run it outside of the cards. It's here, it's running outside of the card. And what's important to notice is it's the same. If I change the code, I'm running a complex system. I interfere with the code. No reloading. My state is still here. If I have filled a dozen of forms before, the data is still here, and I can act on the behavior of the application. And then the very last thing, because if you go and try to build an application without knowing this stuff, you might have trouble. That's what you need to know to run an application. You have to render it, one function. You have to define your app store, one line. And you have to throw your first action to initialize your state, which is going to render the application. And of course, whenever you want to call a server or whatever, you do that in actions, like you would do with Redux. Of course, we have more complex system to develop than an incrementer. This is an example of an application that we are developing at the moment. It's early stage, right? But it's to show you that this is the truth. I'm not lying to you. That's what we are using. Right? So it should work. It might throw sometimes, but it's very important to be able to focus on a small part of your complex system if you want to succeed. If you want to embrace the whole complexity at once, well, good luck. And of course, this is in the form of cards. You have seen, you can, yeah, that's pretty interesting. Actually, what we do, I insist on the developers doing that, is we write documentation, how to write inside the application, okay? And then, of course, when we are finished with one part of the application, we integrate it into a more full-blown application, which is not the case. It's just started, so it's about two weeks development. So we've seen that we have a good reload story to tell. We have dev cards that enable us to focus on one part of the problem, but being part of the whole application with live reloading as well. So it's not just for UI. If you do something that has complexity, you want to use ClojureScript. Something I did not show, sorry, time running. Not only can you change the code, but you can also interact with your application in the REPL. Think the console of JavaScript, right? You can examine data, you can change the data, you can move to another page, and so on. We've seen that we have the modern blueprints, reactive UI, normalized store. Actually, we can also use a real database within the store, so we can tune our queries, we can develop more complex transactions, and so on. And we have seen as well that we respect the Flux architecture. That's not all. That's all for front-end development, but at some point you need to run your application in the cloud with thousands of users. So at PALO IT, we are on the forefront of using this mode of development where you start everything in the browser, transactions, data, logic, business rules. You do everything in the browser in a very interactive way before actually porting it to the backend. And when I say port to the backend, ClojureScript is Clojure. Clojure runs on the JVM. It's a very sound language for doing multi-threaded application, very complex systems. So actually we just port the code to Java runtime. And at that moment, we care about routing, API, server-side rendering, WebSockets, and whatnot, because of course running an application is more complex than having a few forms working together. But having some APIs, having some WebSockets without answering a real issue and a concern of your clients mean nothing. And the next step that we are investigating at the moment is there is this Onyx platform, which is a distributed computation system. I don't know if I heard talking about Scala, so akka, actors, systems, highly distributed systems. It's one of them. And actually, it's got ClojureScript, a JavaScript runtime, which means we can develop, test, proof of concept, highly distributed computation in the browser, and then when we're happy with it, easily port them to a real cluster. So I hope I convinced you that you can try ClojureScript. I hope I convinced you that it's got everything, even at the simplest level, to build, to implement modern blueprints. You don't need libraries. If you need them, it's because you really know what you are doing. Okay, you don't want to. The last thing you want to do is import. I actually use one. Hot code reloading is really a game changer. So yes, I think it's HMO from Dan Abramov. It's not bad, right? But it will never be as good as here. Why? Because JavaScript does not have yet, I'm really voting for it, immutable data structure. The way to go from one state to the other without changing really stuff. Yes, you have Redux, but the first thing that people are doing when they are writing a React component is writing this dot that. And that's a no-go. In ClojureScript, you don't need to do this stuff. I want to convince you as well that fast prototyping is really useful, brings a lot of value to your project. Your clients will love it because they see the stuff that you are making while you are making it. Designers as well love it. And of course, programmers in the first place. So thank you very much. I remember the first time I saw ClojureScript in action, I was like, bro, I come from a Java background. I did distributed systems and so on. I stumbled into Clojure, which has also some mechanism or hot code reloading. But when you see it in a browser, and you are certainly better than me at that, you can make really cool stuff because you are in contact with your design, with your ideas right away without any ceremony. Thank you very much.